All right, everybody, this is a review for test 4, the College Algebra 13-14 co-requisite test 4. And I'm looking at the list. I looked at the test and I looked at this workbook and I found problems that closest match the test. So I'm starting all the way to number 20. So I don't see any of these questions on the test or similar. Possibly there might be a question or two, like number 11 could be on. Maybe I should add that in there. Let me just do number 11 because I think a number 11 might be on the test. So I'm going to add that. So let's do number 11 before we do question 20. All this says, all number 11 says is, what's the answer when you plug -4 into x, right? Whatever's in that parentheses is x. Here's the equation. You rewrite the equation with parentheses everywhere there's an x. And then you put the number in there, and the number they want in there is -4. So when you put this into your calculator, just like this, you can type this into your calculator just like this. 4 parentheses, -4 inside, raised to the second power. Then I bring the power down. Subtract 3 parentheses, -4. There's a difference between subtraction and negative, plus 5. So when you type all this into your calculator, you should get 81. If you don't, you may be a redneck. If you don't, you're not using your calculator correctly. So hopefully you're using your calculator correctly. I mean, if you look at just this, -4 squared is 16 times 4 is 64. -3 times 12 is a positive 12. When you add these up, you get 81. So you don't have to plug it in a calculator. You can do it using the order of operations, but that's what you should get. All right. Oh, I have one more. Oh, I'm glad I did this one. I have one more because this is on a test and I couldn't find an example. What if we do the same problem with -x? So we're going to rewrite the problem for x squared minus 3x plus 5. But instead of a number, we're putting -x in there into the parentheses. Okay, and if it just had an x in, you just put x in the parentheses. And then you do the math. Well, I can't put this into my calculator. Now, so you're going to have to manually do this. -x squared, you always do the power first. So if I just do this, -x times -x. You see, -x squared is -x times -x. Negative times a negative is a positive. So I just get a positive x squared, 4x squared. When you square a negative, you get a positive. You square an x, you get an x squared. Here, -3 times -x is a positive 3x. Negative times a negative is a positive. And we are done. You can't add x squares with x's. You can't add numbers with x's or x squares. So we're done. So I wanted you to see that if you put a negative inside of a square, -x inside of a square, you get x squared. Negative times a negative is a positive x squared. All right, so that's on the test. Something very similar. All right, pretty much everything I'm doing right now for the next 45 minutes or an hour will be on the test. Once again, I looked at the test and I looked at the review. So I'm going to question 20 now. Stop me if you have any questions. Let's describe the transformations. How can the graph of this be obtained from this. So if we start off with x squared, remember x squared is a parabola starting at the center. So all they want you to do is explain what happens when you do this. Well, a -6 on the outside makes the graph go down 6 spots. So this graph moves down 6 spots. A +1 on the inside, remember what a +1 on the inside does. A plus on the inside moves to the left 1 spot. So this graph moves to the left 1 spot, and this is the new graph. And then it transforms. It either stretches up or compresses down, and fractions less than 1 compress down. Maybe I should erase these so we can see what we have here. So this graph went down 6 spots from here. It went down 6, went over 1. There's where the graph is. And then we compress it. We squeeze it down. And when we compress it, we make it fatter. If you remember, do you see how this is fatter than that one? So it's down 6 spots over 1, and it's fatter. All right. And you have about 3, 4, 5 of these transformations. You got several of them. 21, a +1 moves the graph on the outside, moves the graph up 1 spot. A minus on the inside moves the graph to the left. And a negative in front flips about the x-axis. So I want to show you the original x squared. There it is. But if I take that x squared and I move it up 1 to the left 11, and then flip it, there's my graph. I went up 1 over 11 and then flip it on the x-axis. And this graph is this one. This is where it started, the x squared graph. Okay, so you have to know the transformations. Plus or minus on the outside moves it up or down. A minus or a plus on the inside moves it right or left. The negative in front will flip it on the x-axis. A negative on the inside will flip it on the y-axis. All those transformations I showed you. All right, let's look at 22. And there's quite a few of these transformations on this test. I think there's like 5 or 6 of them. So this is an absolute value graph. This is what an absolute value graph looks like. And we want to stretch it by a factor of 7. Stretching it means by a factor of 7, you just put a 7 in front. That's a, that makes it skinnier. You take the ends and stretch it up. Vertically stretched by a factor of 7, the graph is then reflected across the x-axis. If it's reflected across the x-axis, that means there a negative has to be put in front of it. And that's it. So this is what the new graph would look like. It's stretched by a factor of 7. That means it's skinnier. And it's reflected on the x-axis. So it's skinnier than the other one by a factor of 7. And the negative flips it on the x-axis. So the red is the answer. This is what the equation looks like after you do the transformations. The black one is the original graph. All right. All right, let's look at the next one. Stop me if anybody has any questions. Number 23. Once again, there's the original absolute value graph, vertically stretched by a factor of 3. That means it's skinnier by a factor of 3, and shifted units down, 7 units down. So a factor of 3, that means there's a 3 in front of it. And shift 7 units down, that means we're gonna go down, a -7 on the outside, shift 7 units down. This is what the equation looks like. This is what the graph would look like. It's skinnier and 7 units down. Did we say vertically stretched by a factor? Oh, reflected across the y-axis. When it's reflected across the y-axis, I missed that. There's a negative on the inside. So this is what the equation would look like. And it reflected across the y-axis, it doesn't change anything because it's in the same spot. And when you flip them, they're still in the same spot. And I forgot to shift this thing down 7 spots. So it's reflective and shifted down. And it should be skinnier than the one up above. It's supposed to be skinnier by a factor of 3. So this one's skinnier, down 7 spots, and then flipped. Oh, no, it's not flipped. I'm sorry. Let me get it nice and pretty and correct. There's the original. It's down 7. 1, 2, 3, 4, 5, 6, 7. And skinnier by a factor of 3. It's, since the negative is on the inside, it says reflected across the y-axis. That means this side is the same as this over here, and this side is the same as this. So it's just looks like this, it's just skinnier. So all it is really down 7 and skinnier. Reflected on the y-axis, it looks the same on both sides because they're a mirror image of each other. But they're still, since we said it's reflected on the y-axis, you have to put the negative in there. All right, so this is the equation, and this is the graph for that. 24C I'm going to do. And you'll have something similar to this. So really, really understand what we're doing here. So I'm going to take 27C, and they're going to give you a function like this. We don't have the equation for the function. We're just saying that's the function. That graph is our function. And what we're going to do with this graph is we're going to go down 1, and a +2 means go to the left 2 spots. So on each spot on this graph, we're going to go down 1 to the left 2. So all you do is look at each spot, go down 1 to the left 2. See there. Here's another corner, down 1 to the left 2. Here's another corner, down 1 to the left 2. Down 1 to the left 2. Here, down 1 to the left 2. Here's another one, down 1 to the left 2. So if I connect these dots, the graph looks exactly the same, except every point went down 1 and over to the left 2. So it's multiple choice, so you would be looking for this graph. This is the original, and they're going to show you the original. And they're going to then tell you a function, go down 1 to the left 2 with every dot and find a graph that matches that. So it doesn't matter what the function is. Each spot, like on a corner or an edge, needs to be transformed so you can draw the new picture. And you can select the correct graph. It's multiple choice. So all you had to do is select the correct answer. All right, 26. We're going to do this one. All that says is we're multiplying two functions, function f and function g. But first, we're going to put -1 in each of those functions. So we're going to put -1 in each of these functions. So this function, we're going to put -1 in there. And this function, we're going to put -1 in there. 6 times -1 is -6 plus 6. I get 0 for this function. And for g, I get -2 minus 7 is -9. So I need to find fg -1. Well, we put -1 in there, and it means multiply f and g. Well, f is 0. G is -9. 0 times -9 is 0. My answer to this problem is 0. You see, you're plugging -1 into the x's of both functions, doing the math, and then multiplying them. F times g. 0 times -9 equals 0. All right, I want to do this one also. This says we're dividing the two functions. First, we're going to put 0 in each of these. We're putting 0 in each of these. 6 times 0 plus 6. When you do the math, you get 6. Put 0 in each of these. And when you get that, you get -7. This is f. This is g. So it says f over g of 0. So f is on top. This is f. 6, when you put a 0 in there, you get 6. G's on the bottom. When you put a 0 in there, you get -7. We're done. That's the answer. The answer is 6 divided by 7. Positive divided by negative is a negative. So you just say -6 over 7 is the answer. Find the answer for each one. When you put 0 in them, f goes on top. The answer to f goes on top. The answer to g goes on the bottom. And you have your answer. All right. 29. 29 is next. So this is not multiply. By the way, can somebody tell me what this is called? Anybody here? I just want to make sure somebody's listening. What is that open circle? What do I call that? Anybody remember? Starts with a C. Anybody want to? Composite? Yes, it's a composite. Composite. Thank you. Somebody is listening. But you picked the short straw. Says, okay, I'll listen to him. Everybody else, you can go watch TV. So it's a composite. And the way you do composites is you always do what's on the right-hand side first, G -5. So that means I'm putting -5 in the X's for G. Here's G, -2x squared minus 3x minus 4. If you remember composites, you do the right side first. You plug -5 in here. I get -50 when I do that. -5 squared is 25 times -2 is -50 here, plus 15 minus 4, 35. I get -35. I think I get -39 here. When I do this math, I get -39. So this G -5 equals -39. What you do now is put this answer into F. So here's F. 5x plus 1. And you put that negative 30, right? There's F. You put that negative 39 in there. So 5 parentheses negative 39. Then when we have plus 1, I get negative 194. And that's my answer. You do the right side first. You take that answer and you put it in the function on the left. And that's it. So this is the final answer to this problem, if I did it correctly. All right, let's look at 30. Find F53. So we're putting 53 in there. 53 minus 5 over 8. 53 minus 5 is 48 over 8. 48 over 8 is 6. So when I put 53 in there, I get an answer of 6. This answer equals 6. You take this 6 now and you put it into the left, the g function. 9 times x plus 7. Well, we're putting 6 into the g function now, because that's the answer we got from the right, the f. 9 times 6 is 54, plus 7 is 61. And this is our final answer. First, you find f of 53. Plug 53 in the function f. The answer we got was 6. You take that answer and you put it into the first function, which is g. We got 6 for this answer, and you put 6 into the g function. Here's the g function. So you put 6 in there. When you put 6 in there, you get 61. 61 is the answer. Those are composites. That's a circle with, it's an open circle there. Okay, so there's quite a few of these also, probably 3 of these maybe, where you have to find the vertex. So it says identify the coordinates of the vertex to start us off. You can graph this. Even if it said graph this equation, the first thing I would do to graph it is find the vertex. It's a parabola. X squared is a parabola. So to find the vertex, do you remember how to find the vertex? And vertex has an X and a Y component. It's a coordinate on a graph. It has an X and a Y component. If you remember, to find X, you need to do this formula. This is the formula for finding X in a vertex. X equals, what was the formula? Negative b over 2 times a. There we go. So this is how to find the x in the vertex, negative b over 2a. And if you remember, a is the number in front of the x squared. A equals 4. B is the number in front of the x. B is negative 24. And then C is the number without the X, but we're not even using C for the vertex. We're just using A and B. So to find the X coordinate, negative B, B is, we already said, negative 24. Put a negative 24 in there. 2 times A, and A is 4. So when I do this math, negative negative is a positive. 24 divided by 8 is 3. That's the x coordinate. The vertex, the x coordinate is 3. Now I have to find the y coordinate. If you remember, to find the y coordinate, all you do is plug the x back in. We want to find y, so I'm going to plug in the x back into the original equation. Y equals 4x squared minus 24x plus 35, and we have to plug the 3, the x, back in here and put this in our calculator. 4 parentheses 3 squared minus 24 parentheses 3 plus 35. And I get -1 when I do this. That's the y, -1. So this is my vertex, 3, -1, x, 1, 2, 3, y, -1 right here. And so it's a parabola that goes like that. There's no negative in front of it, so it doesn't flip or anything. But it's a parabola that goes right there at the vertex, 3, -1. That coordinate, this coordinate is 3, -1. And if you look, the vertex is at the lowest spot. So we say, it says, is it a minimum or a maximum? The vertex is a minimum. It's the vertex is the lowest spot. If your parabola looked like this, then the vertex is a maximum. It's the highest spot. But our vertex is down here. It's at a minimum. It's the lowest spot. It's called a minimum. Okay. Oh, and okay, this is to see who's listening. First person to type in this answer into the chat box gets 5 extra points on the test. 5 percentage points, not extra points. 5 percentage points. So if you got an 80, you get an 85. I want you to answer this question. What is the axis of symmetry? Take it, type it into the chat box. What is the answer to the axis of symmetry? What is the answer to the axis of symmetry? First person to type in the answer. Oh, now I'm really seeing. And Ashley got it right. It's x equals 3. If you know the vertex, you know the axis of symmetry. The axis of symmetry is always the x coordinate. X equals 3 is the axis of symmetry. So Ashley, after you take the test, send me a quick email saying, hey, I got 5 bonus points coming to me from class, and then I'll add that to your test grade. All right, let's look at question 33. Once again, there's one similar to this on the test. We have a function. A rocket is propelled, and you can read all this stuff. Determine the time at which the rocket reaches its maximum height. Yes, if I never gave it to you, Ashley, I'm sorry. Send me another quick email today, and I'll remember to go back in there and put it. I kind of remember going to do it, and I forgot to add it, I think. But if I haven't, just send me actually, I'm going to write it down, and I'll do it before I leave. Ashley Smith, test 3 bonus. I'm going to add that as soon as I'm done here. Okay. So it says determine the time at which rocket is maximum height. First of all, there's a negative in front of this x square. This is a regular x square. If you put a negative in front, this is what the graph looks like. Do you see it? It has a maximum. If you put a negative in front, it has a maximum. it says determine the time. So we're dealing with time. This is the height, and this is the time in seconds, probably. We want to know the X value. The time is the X value. Do you see right here? Whatever's in the X value, that's the time. That's the X value. Determine the time, it's maximum. In other words, find the vertex. I'm telling you, there's going to be 4 or 5 questions on this test where you have to find the vertex. You have to know this formula. To find X, you do negative B divided by 2 times A. A is negative 16, right there. B is 200. So this is a negative B, put 200 in there, 2 times A, and A is negative 16. So let me put this in my calculator. Negative 200 divided by negative 32. And I get X equals 6.25 seconds. So right here it says determine the time. That's the X value, 6.25 seconds. We're done. That's the answer. At 6.25 seconds, the rocket gets shot up and it reaches its maximum height before it starts going down 6.25 seconds after it takes off. Now, if it says determine the time, okay, that's the time, but what is the maximum height? If you want to know how high the rocket goes, you have to put 6.25 into this function. So let me just do that. Negative 16 times 6.25 squared plus 200 times 6.25 plus 60. This will tell you how high the rocket goes. The Y is the height and the X was the time. So if I put that into my calculator, and the highest the rocket will go is 685 feet. That's the highest. It's at 6.25, it's right here. And the height at that is 685 feet. That's the highest point. All right. I do want to cover, I don't have number 34 circled on my paper, but I do want to talk about this. I'm not sure if I mentioned this in class. I might have briefly mentioned it. I think I have it on another question somewhere. But I'm going to do this one. There's a question that will say, what is the maximum number of turns for this equation? What's the maximum number of possible turns for this equation? Does anybody know? Anybody want to type it in the chat box? The maximum possible turns for this equation. Well, to find the maximum possible turns, I hope everybody's listening. You have to look at the highest power in the equation. The highest power is 3. Then you always subtract 1. So 2 is the maximum turns for that equation. In other words, this has the endpoints of this, and it turns once, turns twice, and there's the equation. You see, it shifts from going down to up. and then up to down. So it has a maximum of 2 turns. If you had an equation that looked like this, the max turns would be 5 minus 1, which is 4. Highest power minus 1 is the max turns that an equation can have, that a graph can have. All right, the highest number of turns. All right, let's go to 38. I have no idea what we're supposed to be doing. Oh, okay. So 38, I don't know what the instructions are, but I have my own instructions for 38. This looks really similar. Find the X and Y intercepts. Find the X and Y intercepts for this equation. So this is, once again, very similar to on the test. I don't think this is what they want me to do for question 18, but this is the way the question is worded, and it looks similar to this. Find the X and Y intercepts. Now, if you remember from a previous test to find the X and Y intercepts, I always write a t-table. I put a 0 in the X, I put a 0 in the Y. When you put a 0 in the X, that's the Y intercept. When you put a 0 in the Y, that's the X intercept. So first I'm going to put a 0 in the X and see what I get. Remember, this is just another way of writing Y. Y equals, put zeros in the X. 0, then 0 squared minus 9, then 0 plus 1 to the third. When you put all this into your calculator, you get 0. I didn't really want to do one. I guess I'm going to get stuck. So that is the y-intercept. Now, x-intercept, when y is 0, so 0 equals x times x squared minus 9 times x plus 1 to the third. Since it's already factored in factored form, and on the test it's also in factored form, you take this x and say it equals 0. You take x squared minus 9 and say it equals 0, and you take x plus 1 and say it equals 0. Even if it's to the third power, you can still say it equals 0. Here, there's one answer. That's an x-intercept at 0. If I take the 9 to the other side, I get x squared equals 9, square root both sides, I get x equals plus or minus 3. So I have two answers here. So for my x-intercepts, one answer we said was 0, the other one was plus or minus 3. I get a negative 3 and a positive 3. And then finally, on this one, if I take the third root of both sides, I still got x plus 1 equals 0. Take the 1 to the other side, and I get x equals negative 1. So x-intercepts, these are my x-intercepts here. This was my y-intercept, but these are my x-intercepts. There are 4 of them. X-intercept make y equal to 0, and all the factored forms, each factor piece has to equal 0, right? It's separate. All right. 39. Find a polynomial degree of 3 with real coefficients that satisfy the given equation. All right, so we have zeros at -2, 1, and 0. In other words, you're going to write an equation at -2. That means you put a plus 2 inside. Positive 1, you put a -1 inside. 0, you just put an x, and normally you put the x in front. So we have all 3 zeros in our equation. This is my equation, the function. And then now it says, don't forget, We also have, when we did this, you have to put an A in front because you're not sure what A equals. So I have an A in front. In the original equation we just wrote down, I have to put a 2 everywhere there's an X. And I have to put a 40 in the Y spot. So I'm putting a 40 here in the Y spot. Everywhere there's an X, I put a 2. There's another X here, I put a 2. There's another X here, I put a 2. Okay, so we put the 40 in the Y spot and the 2's all in the X spots. On this side, 2 times 2 is 4. I get A times 2 times 4 times 1. 2 minus 1 is 1. Equals 40. So this is 40 equals 2 times 4 is 8 times 1 is 8. So I get 8A. Divide both sides by 8 and I get A equals 5. So the answer, my polynomial, this is my answer here, but instead of A, I put a 5 in that spot. 5x parentheses x plus 2 parentheses x minus 1. That's the answer. That's the function. You had to first find the x-intercepts, and they gave us all the zeros. 0 is an x-intercept, and then you had to put an A in front and find the A using the x equals 2, y equals 40. That was 39. 40 is really similar. 43 is next. Find the equation for the vertical asymptotes. The vertical, remember, the top is called our zeros or the x-intercepts when we have a rational function. The bottom are our vertical asymptotes. Okay, and it says give the equation for vertical asymptotes. Vertical asymptotes always start with x equals. And if it's not factored, you have to factor this, x squared plus 4x. If you look, an x factors out of there, then you're left with x plus 4. 1x factors out. So we're left with x plus 4. So the vertical asymptotes are right here, -4. And since there's nothing there, also 0. So we have 2 vertical asymptotes on the bottom. The factored form, opposite sign, -4, and then if you don't have a plus or a minus, it's like saying plus 0, which x equals 0. So those are my 2 vertical asymptotes. 44 is on the test. It says, give the equation for horizontal asymptotes. Vertical asymptotes start with x equals. Horizontal asymptotes always start with y equals. And look at the highest power. If the highest power are the same, the answer to this is the coefficients in front, 9/4. That's if the powers are the same. Now, don't forget, there's 2 more scenarios. If I had this, if top power is larger, no horizontal asymptotes. Remember, you have a slant asymptote or an oblique asymptote, and we're not even talking about that. So then next, if the power on top is smaller, then you have y equals 1. It's always y equals, oh, sorry. Let's say the top is 2 and the bottom power is 4. If the power on top is smaller, the horizontal asymptote is always y equals 1. You got to have those three. If they're the same, the horizontal asymptote is y equals the numbers in front. If the top power is larger, there's no horizontal asymptote. If the top power is smaller than the bottom, the horizontal asymptote is always y equals 1. Always. And 48. Let's try to write this equation. X-intercepts at -1 and -2. Remember, x-intercepts are on top. -1, so we put a +1. -2, so we put a +2. Y-intercepts are none. Vertical asymptotes are at 0. Vertical asymptotes are the bottom, 0 and -3, so we put x + 3. The horizontal asymptote is at y equals 1. Wait. Since the powers are the same, I have x squared here, x squared here. We have a 1 and 1 in front, so it is y equals 1. But I mean, the main thing is to understand the top are the x-intercepts, the bottom is the vertical asymptotes. And that's it. I think that's the test. 44, 48, that was the last one. A little quicker than I thought. Yeah. Any questions? All right, I hit enter.